Guys, let's look at this problem right here. Here this question is asking, state the orders of the following differential equations and determine whether they are linear or non-linear. Okay, now let's look at this one. The first one, first let's decide the order and then we can figure it out whether it's linear or non-linear. To find the order, what we do is we look at the highest derivative power, and in this case x double prime is the highest derivative, right? So this is going to be order 2. Order 2. Now let's look at this one. This is d cube y over dx cube. So d cube y mean is third order, right? Order 3. And here we have x square y power 5 and x power 5 y double prime y. But here you have to be careful. This bracket power 5 is representing the derivative, fifth derivative. Okay, so when you have this one, this is order 5. That's our highest order, right? Order 5, and that's how we decide the order. Now to decide linear, you have to look at these two conditions. It shouldn't violate these two conditions, the first and second, right? The first one says the dependent variable and all of its derivative are always to the first power. Okay, for example, this one is linear, but in order to like violate this one, what has to happen is, for example, if you have x double prime square, something like that, then it's non-linear. Okay, for example, for this one, if you have d cube y dx cube square, something like that, so this is non-linear, right? So it shouldn't happen in order to be linear. Now from this one, if you look at this one, this is not violating the first rule because we don't have any square for these derivatives, so this is not violating the first rule. Let's look at the second rules. There's no products of the function y and its derivatives. So for example, in our case this is x. For example, if you multiply, if there's an x multiplication with x double prime, this is not linear. Or you can like x power, like anything that related to x, if you multiply this one, that's not linear. Okay, for this one, since the second one is related to y, since our order is related to y, if you have any multiplication of y with the derivative, that's not linear. Okay, so this one shouldn't happen, and that's what the second one says. But here we don't have any x multiplication, only the orders are there, x double prime, x prime, x. We don't have any other x multiplication, so this is linear. This is linear. Now let's look at the second one. D cube y over dx cube is equal to 1 over y square. This seems like this is linear, but if you carefully look at this one, this y square, if you bring this one to the other side, this is going to multiply this d cube y over dx cube. That's violating the second rule. The second rule says there are no products of the function y and its derivative. If we bring this one to the other side, we are going to have y square times this d cube y over dx cube. So that's going to make this, that's going to violate the second rule, right? So this is non-linear. Non-linear. And the third one, we have x square y double prime. Let's look at the conditions. Here the first, the dependence variable and all of its derivatives are always to the 1 power. Here we don't have any, like if we have y power 5 and something like square or something like that, then it's non-linear, but we don't have anything like that, right? So this is linear. And let's look at the second condition. There are no products of the function y and its derivative. We don't have any multiplication with y of anything, right? So we don't, it's not violating these first two rules. It means this is linear. Okay, and that's how we decide the linear, whether a given order is a linear or non-linear. I hope this helps. Thanks for watching.